Let's do one more problem about a carbocation rearrangement. So here you have a primary alkyl halide. Notice that what you have at the alpha carbon, that's your alpha carbon, is just one R group. So let's say, similar to the reaction that we did in another video, let's say that we are doing this in methanol and heat. So again, we're looking at another solvolysis reaction. And we're going to propose then in the first step, the loss of a leaving group to form the following. So that is a primary carbocation, which we know is not stable. And here we have the order of stability. So tertiary is more stable than secondary, and the primary. So now that can, we're going to explain now another type of rearrangement, which is an alkyl migration. So we can have, here we spoke about a hydrogen shift before in another video, right? Shift or methyl. But we can have methyl shift. We can have an alkyl migration, a larger chain. Say, for example, I'm going to migrate now this bond over there. In doing so, I am creating the following. Notice now I'm expanding the ring. So I'm now making the bond here over there. So now it's a larger ring, and we're gonna have this carbocation. Well, let's change the positive charge to another position so that it looks better when you thinking of the previous structure. So now carbocation on the right is secondary, which is more stable. So this ring's expansion happen if you can form a more stable carbocation. So if you are in say, conditions of a solvolysis, then second step after you do, so first step was, say, loss of leaving group, iodide departed, you form a carbocation, is primary. Second step here is the rearrangement to form a secondary. Third step here, we're going to have a nucleophilic attack. And again, the nucleophilic attack doesn't happen here, which is the stable carbocation. It's going to happen here. That is going to rearrange. And after we do that, so this is my electron-rich species, right? My nucleophile attacking over the electrophile there. And I will have now, let's write it over here, metal, and now I have a formal positive charge. And last step is a proton transfer step in which methanol is going to act as a base to remove the hydrogen here. Let me see how to put the arrows best, removing this hydrogen. Then electrons are going to go back to the oxygen, and my final product is this ether, right? So again, but we have applied what we learned about carbocation rearrangement to predict the product, the major product. So doing recap of what we did. So first step, we had a primary alkyl halide, which formed a primary carbocation under this condition, which is solvolysis reaction. We know primary carbocations are not stable, so we have here an alkyl migration. So that bond over there, and we have done what is a ring expansion. So we created a larger ring, and that is observed in, so we propose that because this is observed experimentally. And so lastly, we have a nucleophilic attack, methanol, which is, remember, solvolysis with methanol, acting as nucleophile. You're creating this intermediate, which is still protonated, and now I need another step, proton transfer, in which methanol acts as a base. But our point is that rearrangement will happen whenever we can get a more stable carbocation, not the other way around. So you will rearrange primary carbocations to secondary and secondaries to tertiary, but doesn't happen that way. You will always, this is absurd. It will happen when you can form a more stable carbocation. So if they can happen, they will, getting a more stable carbocation.